So hello guys, in this video I will try to cover around 6 to 7 very important question on gamma function and beta function also. So without wasting much time, let's start. So first of all, you can see the question, how we will solve it. You know, the integral form of gamma function is looking like that, 0 to infinity e to the power minus x to the power n minus 1, sorry, this is gamma n dx. But you can see this is e to the power minus x square. You can't integrate it using the basic rules. So what is the process? First of all, you have to take, you have to make this integration to this. Hopefully you can understand. So you can see this is minus x and this is minus x squared. So I'm taking minus x, x squared is equals to z. So x is equals to root z. So definitely dx will be equal to z to the power half minus 1 into half into dz. Basic differentiation. Now this is z to the power half minus 1 divided by 2 dz. I am not doing this algebra just for making it simple. So this is the integration. We are replacing x square with z. So this is e to the power minus z, and we are replacing dx with that. So this is z to the power half minus 1 by 2 dz, and the limits, you can see x square equals to z. So when we will put 0 at x square, we will get 0. Basically when x is 0, z is also 0. When x is infinity, z is also infinity. So it is looking like very similar to gamma function with a half, and the value of n is half. So now gamma half is root over pi, and the answer is root over pi by 2. Now you will ask why gamma half is equals to pi. There are two formulas which you can use for getting the value of gamma half. So first of all, first formula is this, is equals to pi cosec n pi. Let's put n equals to half. So gamma half into gamma 1 minus half, which is again gamma half, is equals to pi into cosec n is equals to pi, n equals to half. So this is cosec pi by 2, right? And you know that the value of cosec pi by 2 is nothing but 1 by sine pi by 2, which is 1 by 1, which is 1. So this is pi. Now this is gamma half into gamma half, which is basically nothing but gamma half whole square. So the whole square of gamma half is equals to pi. So the value of gamma is nothing but, gamma half is nothing but root over pi. So it's very easy to find out the value of gamma half. So let's move on to the next example so that you can relate with the question also. In that question, we will deal with minus infinity to infinity e to the power minus x squared dx. In that question, the question is very similar to the previous one, and using the even odd property, you can't define the answer. Definitely, you maybe you will see like there is minus a, there is a, and basically infinity, a is equals to infinity. So you can use the even odd property, and the answer will be 0. No, in that case, this is x squared. So the function will not be changed, right? If we are putting f of minus x, then the function will be same, remain same, right? So how will we proceed in that case? So basically you can see we have to break the limit. In maximum cases where we can't deal with the even odd property, in that scenario where the lower limit and upper limit is same with a negative sign at the lower limit, in that case we will deal with the function, the limit breaking of integration. So minus infinity to 0, whatever the limit is doesn't matter, I am breaking it for making it into gamma, for converting it into gamma function. So this is e to the power minus x squared dx plus 0 to infinity e to the minus x squared dx. Now there is a property of even odd which is called f of minus x is equals to f of x. In that case, you can see if I am putting f of minus x at that function, because basically fx is nothing but e to the power minus x squared. If I am putting minus x at here, then it will not be converted into any kind of negative function or something like that. So f of minus x is to minus x, and for that condition the integration will be nothing but looking like that. 0 to infinity 2 into same function, which is f of x dx. And now f of x is nothing but e to the minus x square dx, 0 to infinity 2. Now you can see basically we had done this integration in the previous question, so the answer is root over pi by 2, but there is a 2, so 2 into root over pi by 2, just so the answer is pi. This is known as the Gauss integral, and the graph of e to the minus x square is nothing but looking like that. And in the previous question, I mean in that question, we have to find out this area, I mean the positive portion only, and in that question we have to find out the negative portion plus the positive portion. So this area will be root over pi by 2, and this area will be root over pi by 2. So the total area will be root over pi by 2 plus root over pi by 2, which is 2 into root over pi by 2, which is basically root over pi. So it is very easy to understand. There are multiple processes to solve the Gauss integral. We can solve it using the double integral also. We have to use the polar coordinates. We have to solve this kind of integration, double integration, where e to the power minus x square plus y square dx dy with 0 to infinity, using using the polar coordinates and solving this integration. I can easily find out the value of Gauss integral. It is nothing but e to the power minus x square dx integration 0 to sorry for a mistake, 0 to infinity whole square of that. Don't need to worry about that. If this will come, I mean this integration will come, then you need to solve this integration using the gamma function. Don't need to worry about that. So let's move on to the next question, which is too much important question. So basically in this question we have to prove this is equals to infinity, or specifically as we are talking about gamma function, and as I had told to you in the previous video, the gamma function is converging when the value of n is greater than 0. So we will not take 0, we will take 0 plus, which is basically a number which is very close to 0, but it's a positive number. Let's say 0.00001 or something like that, or more smaller than the previous one which I have told you. So basically how we will prove? Using the improper integrals. Be careful. So basically the gamma 0 positive is nothing but integration of 0 to infinity e to the power minus x to the power n minus 1, where n is 0 positive, so you can easily put n is equals to 0. So 0 minus 1 dx. You can see this is 0 to infinity e to the power minus x divided by x dx. Now basically if we are talking about infinity, then the value of the function, if we are talking about limit x is tending to infinity, the value of the function is nothing but 0. Why? Because basically we can take the e to the power minus x in the denominator, and the value of this denominator is equals to infinity, so 1 by infinity is 0. But when we will deal with the lower limit, then we will see this portion will be 1, but this is 0. So the denominator is 0 and the upper portion, I mean the numerator, is 1. So 1 by 0, which is undefined. So we have to use the improper integrals. Maybe it will converge or maybe it will diverge or something like that. We have to prove it. The answer is it will diverge, but how? Let's prove. So first of all, you can see the lower limit is making the problem. So we have to use limit epsilon tends to 0 positive, where epsilon is greater than 0, but always epsilon is less than infinity minus 0, which is basically infinity. So 0 positive, this is 0 plus epsilon, because we have to stay at the region from 0 to infinity. If we are subtracting epsilon from 0, then we will not be in the region which we need to talk about. So this is the function dx. Now you can see this is limit epsilon tends to 0 positive. This is epsilon, this is e to the this is infinity, e to the power minus x, this is x, this is dx. Now maybe you will see this kind of integration during any kind of like differentiation under integration or something like that. So in this integration we don't need to solve it, we just need to understand, which or maybe you can use the by parts, integration by parts you can use. So if we are using the integration by parts, then what will happen? Basically, if we are using the integration by parts, the first part will be solved, minus there will be another integration which we have to solve. But wait a moment, the first part will be solved with a limit 0 to infinity, and after solving, if we are going to put the limits, then infinity will not make any kind of problem. But if we are putting epsilon, then after that we have to put this limit also, then we will see the integration will not exist. Let me show why. First of all, if we are using the integration by parts, so this is 1 by x, this is integration of e to the power minus x, which is minus e to the power x, so minus e to the power x, minus x, right? Minus 1 by x square, sorry, minus 1 by x square into e to the power minus x with a negative symbol into dx. I am doing a simple step jump. If you can't understand, then please understand the by parts first, then maybe you will be able to understand. However, so with a limit 0 to infinity, basically epsilon to infinity. Now infinity will not make any kind of problem. When we will put infinity, then it will be like 0. This is minus minus will be cancelled out. This is minus 0 to infinity e to the power minus x by x square dx. Very nice. This is again epsilon, not actually 0. So when we will be going to put the lower limit, which is epsilon, then we will see this is nothing but plus e to the power minus epsilon by epsilon minus sorry, there will be no doubt, sorry for a mistake. Now if we are putting the limit, I am not solving it properly, but we need to know this term will be in the integration. So you will see, if we are putting the value of epsilon, then this integration will be an integration. Basically, you have to solve it in the next step, but we don't need to solve it actually, because we can see this is not existing. Why this is not existing? If we are talking about limit x tends to 0 1 by x, this will not exist, because if we are talking about the LHL and RHL, both will be like, if we are talking about LHL, then LHL will be x tends to 0 minus, that means LHL will be minus infinity, and RHL will be x tends to 0 positive, RH will be positive infinity. So negative infinity and minus infinity. So this limit will not exist. So the answer is infinity. This integration, I mean basically minus of this integration, let's say this is I dash. So minus I dash plus infinity, which is actually infinity. So you can see, or you can understand the question again. So we don't need to talk about it more. Basically we can easily prove that gamma of 0 positive, or specifically gamma of 0, is not converging, or even if it is converging, then the value of this integration or value of this function is equals to infinity or something like that. And if a function has a value which is infinity at a point, then maybe we can say it is not converging at that point. So it's a theory. And let's move on to the next question, which is too much important. Again I am saying which is too much important. So in this question, we need to use the beta function, the primary form, or you can say the primary integral form of beta function. So you can see the beta function is looking like beta of m comma n is equals to 0 to 1 x to the power m minus 1 into 1 minus x whole to the power n minus 1 dx. Now in that case, we just have to make this integration into that form. We just have to convert it in that form, so that we can solve it using the beta function. How will we proceed? So let's see. First of all, you can see this is x minus a, and we just need to take x minus a is equals to x, or you can say equals to z. Actually x minus a is equals to z. Okay, fine. So the value of x is equals to z plus a. So dx is nothing but dx is nothing but dz, right? Very nice. Well, I am not proceeding with that. um, Basically we can proceed with this, like this is x minus a whole to the power m minus 1. This is b minus of x minus a minus a. We can write this function or in that way, right? This will be b of minus x, this will be plus a, this will be minus a. Plus a and minus a will be cancelled out, so this is b minus x. We can write something like that. So this is x minus a m to the power minus 1. This is b minus a x minus a whole to the power n minus 1. Very nice. Now we are taking common the b minus a from that portion. So this is x to the power a whole to the power m minus 1. This is b minus a whole to the power n minus 1 into 1 minus x minus a by b minus a. Now we can take a simple, you can say the very simple transformation for making or for converting this function into that function, which is x minus a by b minus a is equals to z. So how we should proceed after that? You can see the value of x is nothing but z into b minus a plus a. So dx will be equals to b minus a into dz. I'm doing a simple step to make us see, and I hope you can understand basically. So we are replacing this into this. So x minus a will be z into b minus a only. Okay, fine. This is z into b minus a whole to the power m minus 1. This is b minus a whole to the power n minus 1. This is 1 minus z whole to the power n minus 1. Integration from 0 to 1. Now why the limit is not changed? The factor is this, because if we are putting let's say if we are putting the lower limit at a, hopefully it is visible. I mean, if we are putting the lower limit, then a minus a will be 0, so the lower limit will be 0, and the upper limit will be 1. Why? Because the upper limit of x is b. So if we are putting b here, then it will be like b minus a by b minus, which is 1. So z is equals to 1 at the upper portion. I mean the upper limit, z is equals to 1. Now we have to replace the dx with that. So this is b minus a into dz. So after that we just have to do a simple algebra so that you can solve it easily. So this is 0 to 1. This is z to the power m not n, m minus 1. Definitely it will not matter actually, but still okay. This is 1 minus z to the power n minus 1 into dz into, we are taking out b minus a whole to the power m minus 1. Now I'm doing a simple algebra or nothing more than that. This is what? This is beta function. This is beta m comma n or n comma n, whatever you can say, doesn't matter actually. So this is into b minus a whole to the power m minus 1 plus n minus 1 plus 1. Plus 1 and minus 1 will be cancelled out. This is b minus a whole to the power m plus n minus 1 into beta of m comma n, or you can say b minus a whole to the power m plus n. This is m not n actually. Sorry for a mistake. Into beta of n comma m, as we know that beta of a comma b is equals to beta of b comma a. However, we can say, so this is the answer of this integration. In some of the cases you will see the examiner will give you the value of m and n or something like he will give something value of that. I mean, just assume this is x minus a whole to the power 3 into b minus a whole to the power 4 dx from a to b. Now in that case you don't need to worry. You just have to replace 3 with m minus 1, and in that way you can easily find out the value of m, which is basically 4. As same as you have to find out the value of n by replacing n minus 1 equals to 4, so n equals to 5. It's very easy to understand. Now let's move on to another question, which is again and very important question. So now in that question we need to solve this integration dx by root over sine x into root over sine x dx. The limits are same, 0 to pi by 2, 0 to pi by 2. Maybe you will think we can cancel out root over sine x and root over sine x. The answer is something like pi by 2 into pi by 2, because this is it will be cancelled out. So this is pi by 2. The answer of this integration is pi by 2. This integration is pi by 2. So the answer is pi square by 4. No, you are wrong, because we can't multiply actually two integrals. They are different. The function is different, so you can't multiply actually. If we have to add, then we can easily add them. Like if we have to add, let's say this is not minus, I mean this is not multiplication symbol, this is, let's say, addition symbol. In that case you can do that. And the function, main function, let's say fx is equals to 1 by root over sine x and gx equals to root over sine x only. So the after addition the function will be converted into, let's say, hx. So hx equals to 1 by root over sine x plus root over sine x. So however, in that case, how will we solve? Using the beta function we can easily solve it. We can use that formula, which is 2 into 0 to pi by 2 sine 2m minus 1 x, this is beta m comma n, okay, is equals to cos 2n minus 1 x dx. Using that formula we will be going to find out the value of this integration and also this. So first solve this portion. So this is sin x whole to the power minus half into cos x whole to the power 0, because we are replacing 1, I mean we are multiplying 1 with sine to the power minus half, which is basically sine to the minus half. So we can replace the 1 as like cos x to the power 0, sorry, not 0, actually 0, sorry. This is dx, this is 0 to pi by 2. Now we can replace minus half with 2m minus 1 and 2n minus 1 with 0. It is 0. So 2m is equals to 1 minus half, which is half. So m is equals to 1 by 4. And 2n minus 1, I mean n is equals to half basically. Right. It is very easy. But there is a 2 at the formula, so you have to use we have to multiply a half and a 2 also. So you can replace this function as beta, I mean half into beta 1 by 4 comma half. As same as we can use this formula for this also. Now the value of n will be same. We have to replace the value of m only. So basically 2m minus 1 equals to half in that case, not minus half, right? So 2m is equals to 3 by 2, so m is equals to 3 by 4. N will be same, half. Very nice. So into half into beta of 3 by 4 comma half. Now this is 1 by 4, this is beta of 1 by 4 into half. So basically you can replace it of like gamma 1 by 4 using the relation between gamma function and beta function, which we had told at the previous video. So this is gamma half, this is gamma 1 by 4, this is gamma half divided by gamma of 1 by 4 plus half, which is 1 plus 2, right? I'm doing a simple algebra. This is into gamma 3 by 4 into gamma half. This is gamma 3 by 4 plus half. So right, now you can see this is 1 by 4, this is gamma 1 by 4. The value of gamma half is root over pi, and there is not only one, there are two gamma half. So root over pi whole square, which is root over pi, I mean which is pi, sorry, into gamma of 3 by 4 divided by, be careful about that, divided by, you can see this is gamma of 3 by 4 into, you can see this is gamma of 5 by 4, but we can replace 5 by 4 as 1 by 4 plus 1, right? So now this 2 will be cancelled out. This is pi by 4, this is pi by 4 into gamma of 1 by 4 divided by, we know gamma n plus 1 is equals to n of gamma n into gamma n, sorry. So this is 1 by 4 into gamma 1 by 4, right? So gamma 1 by 4 and, sorry, gamma 1 by 4 will be cancelled out, and 1 by 4 and 1 by 4 will be cancelled out, so answer is pi. This is the answer. So you can easily find out the answer. So basically these are the examples which I want to tell, and hopefully you can understand all the questions. This is all about this video. In the next video maybe I will start the differentiation under integration, and also I will introduce you all with the Feynman's trick, Feynman's trick, or something like that. So this is all about this video. Thank you for watching. If you want to subscribe, if you want to comment, if you want to like, if you want to share, then do it. Goodbye.